velocity.
Followed by everyone goes all the way nils still make across the He was fine.
Right, here we go.
Sure.
And one caution. Listen.
More than my.
The answers that are in the back of this packet, all eyes on me. Everyone can look. Drew, look up. Drew's tired. Let Drew sleep. Okay. There we go. It's all good. Hey, the answers in the back of the packet, listen close. Some of them are just wrong. Like somehow it didn't get created properly. So I'm going to work on fixing that. But don't really pay close attention to the answers. For the first 4 problems, I'm hoping we get half of the homework done together during class. And then for the last 4 problems, I'll kind of highlight the numbers in the answers that have validity, but you kind of ignore the rest for now, okay? Understand? Okay. So look at number 1. The situation is not new. It was in the blue packet. So this is actually just part D of the same FRQs that you saw in the blue packet that you did for homework. Okay, the question says, at what time between 9 and 23 does the model predict that the number of people in the park is a maximum? Always stop at commas, periods, question marks. See what they're asking. So they want to know when the number of people is at a maximum. Okay, nowhere in the reading do they give a symbol to represent the number of people in the park. They give symbols to represent the rate at which people enter and the rate at which people leave. But they don't give a symbol for the number. So you will find that it's much easier to get a solution written if you invent a symbol to represent the number. I'm not super creative, so I just go with n of t equals number in park. So you write that down. If you don't write it down, the grader can't give you any points because he won't know what n is representing. And he or she will not assume to know. You must tell them. So n of t, number of people in park. You don't have to have perfect grammar. It's good enough. So. We're supposed to figure out when n is greatest. So you start the problem by memorizing the following fact. That n is always greatest at a critical or endpoint of n. So n of t is always greatest at either a critical or endpoint of n of t. A warning. Don't get n and n prime mixed up. The moment you are writing your solution and the grader sees that you have those mixed up, you're going to get 0 points because your answers don't make any sense. So be cautious. We're talking about n. N is greatest where n has a critical or endpoint. Okay. Question? Awesome. Let's see. So we got those. Oh, so we need n prime then because we find the critical points of n by identifying where n prime is 0. So let's see. N prime is the rate at which n is changing. The number of people in the park goes up or down based on the rate at which people enter and the rate at which people leave. So n prime is simply the in rate subtract the out rate. And you can memorize that. There's a lot of AP problems that will deal with an in rate and an out rate. The overall rate is simply the difference. So, question?
What's the n prime, the derivative?
That's the derivative. No, it's perfect. Does that make sense now?
Yeah.
So yeah, again, make sure that you keep straight when we're talking n prime, when we're talking n. So, anybody else? Cool. So I need to find out when n prime is equal to 0. So n prime of t is equal to 0 at t equal. So I get out my calculator. And I load up this problem. So I put into y1 my rate at which people enter the park. y2 is the rate at which people leave. I want to graph n prime, so I put n prime in y3. N prime is just y1, subtract y2. Go wave at me if you need help with your calculator. Just pull this out for me. Just distracts me. I'm just treating your car use wallet, first child, credit card, something of value. There we go.
Thank you.
You're welcome. Who has this on their screen? Another minute. Window should be 9 to 23 because that's the hours that the park is open. So a lot of people didn't graph the n prime. You don't have to, I suppose, but I find it useful. So again, I put into y3, y1 subtract y2. That's my graph of n prime. So, hey, so there's only one time when the derivative of n is equal to 0. So find that time. Make sure you store that value in your calculator for later use. Someone have the time?
15.75.
So put that in A, so you can use that later. So raise your hand if you're able to successfully find the 0. Show me. Show me your hand. 2 points. You would have a question when you need to come look at something.
Wait, how do you store?
Store. So on my calculator, I find the 0. So let's see, second trace, 0. I need to find the 0 on that black. So there we go. Left bound, right bound. Yes. So I'm trying to store this x value. So on the main screen, I type x, store alpha A.
Oh, okay. Thank you.
Yeah. For Allison for asking. Okay, cool. Now, all eyes on the board, everybody. So try to look up for just a minute. You're good. Make sure what I'm about to say makes sense. If it doesn't, wave at me so we can say it again, say it differently, whatever. Okay, the blue is the rate at which people are entering the park. The red is the rate at which people leave. So the rate at which the number in the park changes is the difference between the blue and the red. So when the blue is greater than the red, there's the n prime is going to be positive. Okay, the number in the park will be going up. Right here, when the blue and the red are exactly the same, well, the number in the park won't be changing because the rate coming in will be exactly the same as the rate going out. That's why the 0 is at that point. Okay, question. Awesome. Back to your writing. Okay, so we have this. So now we write on our paper n of t. And again, please note, you are constantly switching from n and n prime back and forth. If you mess up one of them, you're not going to get any points because your answer won't make any sense. So be cautious. Don't casually write n prime or n. Think about why you're writing it. So back to n now. So n is, we're looking for the greatest number. So n is greatest at t equal 9, a, or 23. Question. Please.
How did we get that answer?
So this comes from this math fact that the value of n is going to be greatest for sure, either at a critical point of n, and n only had one critical point, and had only one place where the derivative of n was 0 or undefined. So we have the critical point, that's A. But n could also be greatest either where n begins or where n ends. That's what we're calling the end points, the beginning point or the ending point.
So it could be any of those three?
Right, so this statement here is just a more specific version of the red. So the red's the generic version. So 2 points for Elijah. You don't actually have to write the red on your work. I have you write it in class because I want to make sure you're not forgetting, but it's not required. The orange is required to get points. You've got to declare to the grader, hey, of all the times between 9 and 23, I don't need to check all of them. I need to check 3 of them.
Okay, so that's not the final answer. That's showing up more work.
Right.
Okay.
The way they'll put this in the scoring guide is they'll say, did the student check for the candidates? Candidates meaning the possibilities, the possible correct answers. Please.
I
So in this problem, the endpoint really doesn't make a whole lot of sense because they're talking about an amusement park. So you would expect that at an amusement park, the number of people in the park would start out at 0. No one's there. Then the number's going to go up, maybe it goes back down, maybe it goes back up, whatever. And eventually, by the end of the day, you'd expect the number in the park to be back to 0. So for this problem, the endpoints really don't fit. But if we're talking about a tank of water, which is another common AP problem, the tank of water, like the gallons in the tank, may start out fairly high, and then the number of gallons might drop and then go back up and then drop and go back up again. So it's very possible that the tank could be fullest either at the beginning or the end. So you always have to check the endpoints. 2 points, please.
Why does the critical point show where it's the greatest? Because if that's on the NFT graph, and the NFT is the number of people in the park, and the critical point's where it's 0 undefined, right? So why is that the maximum?
So the reason why a critical point of n could be the highest point on n is because n has, so it's back to the white sheet I gave you in September. N has a critical point where the tangent slope of n is either 0 or undefined. So in this picture, n would have a critical point here, here, and here. So these are definitely possible places where n could be highest.
Oh, yeah.
That's
okay,
all.
I just wasn't remembering critical point right.
Does that make sense?
Yeah.
2 points. Good deal. Awesome. So back to our work. Okay, so n's greatest at one of those 3. So now we just write down what the number of people in the park is at each of those times. So we write the number in the park at time 0, no, sorry, not time 0, time 9 is 0. The number in the park at time A is going to be, we start out with 0 in the park, and then we can integrate the rate at which the number in the park is changing from time 9 to time 15. If you integrate the rate, the fundamental theorem, wow, that's rough. The fundamental theorem, so like some evil plot. What's the name of that show? Phineas and Ferb. There we go. Sounds like a Phineas and Ferb episode. The fundamental theorem. What's his name? Dr. There you go. All right. So anyway, the fundamental theorem says that if you integrate the rate at which the number of people in the park is changing, the integral never calculates how many people are in the park. The integral calculates how much the number of people in the park changes. Please make sure you memorize that. The integral never calculates how many. It always calculates how much something changes. In this case, we start with 0. So the change is the same as how many there are. But the integral always calculates the change, not the amount. The integral always calculates the change in the amount, not the actual amount. So we're going to integrate the rate at which n is changing over this time period. And the integral is going to tell us by what amount did the number of people in the park change during this time period. There is no more important rule than that one to memorize. Does anyone need me to say it again? Just wait. Okay. So the fundamental theorem says, if you integrate, I'm using this as an example. If you integrate the rate at which the number of people in the park is changing, the integral is going to calculate by what amount did the number of people in the park change. So you're integrating the rate at which the number of people in the park is changing. The integral calculates by what amount did the number of people in the park change. So the integral always gives you a change in the amount, not the actual amount. So do this on your calculator. Go. And again, be very cautious in your writing. Don't mix up n and n prime. We're integrating n prime to determine by what amount does n change. That's the fundamental theorem. Integrate n prime to figure out by what amount does n change.
I'd be with my knees on stage. There. Say perception.
Who has this, please? Come here. Who has this? You have to have all three decimals. It must say 0.680, otherwise you do lose a point. Who has this? Point. Please.
In the instruction it says round to the nearest whole number. Do you wait to do that until after?
Perfect. So this is my analysis. While I'm analyzing, I don't round. And then the final answer, yes, for sure. 2 points. Okay. We need to find the number of people in the park at time 23. So we say n of 23 is going to equal 0 to begin with. We then find out by what number will the amount of people in the park change during the hours from 9 to 23. So we integrate n prime again to find the change in n. Please, Isaac.
On the AP test, will they always give you like the base value, or will you have to calculate it sometimes to figure out like where you're starting from?
Gotcha. 2 points for that. 3 actually. Giving the base value is most common. Sometimes they don't give you the value at the beginning. They give you the value at the end. And then you can still use the fundamental theorem kind of backwards to find the other values. But they have to give you some value of n, because the integral is never going to tell you what n is. It only tells you how much n changes.
Yeah. Okay.
Perfect. So somebody have a number here?
1.014.
1 poor security guard left in the park at the end. So, questions? Awesome. All that's left now is to write a concluding statement. So I always go back and read carefully the problem to make sure I did what Cambry's talking about. Make sure I answer what they want. At what time does the model predict? Warning. No, I've seen students do all of this perfectly, and then they don't go back and reread, and they forget to write down the time when the number of people in the park is greatest, and so they lose a point. So just go back and read slow and careful. At what time does the model predict? So I'm going to come down here and write at t equal 15.795. They didn't tell me to round it, so I won't round. The units are hours. At t equal 15.795 hours, n of t is greatest. And they do want the number at that time rounded to the nearest whole number. N of t is greatest where the number in the park at that time, 15.795. Oops, forgot the 7. Equals, and now I round, 3951 people. If you don't round, you will lose the point. So. Questions, please.
Do we not need to test t equals 9?
No need to test there because they tell you at the beginning no one's in the park. No, it's a good question. 2 points, please.
But I feel like the problem in the last packet, I said I was rounded like when it's right when the sum in the answer is not correct.
like rounded here.
Yeah, is that not correct?
So the rule for the AP test is don't ever round until they ask you to round.
Okay.
And so as I'm doing my analysis, I wouldn't round.
Okay, sounds good. Thank you.
Good question. 2 points. Anyone else? Awesome, next one. And this is what's needed to get the points because it is a written test. So,
Sorry. So like, what makes you, when you read that, like choose to use n prime? Like, is it just because you don't even have an n? Like, it's asking for like n of 23 and stuff. Why do you use n prime?
So my logic is this. I read the question. It says, at what time does the model predict that the number of people in the park is greatest at a maximum? So that's where I'm taking, okay, I want to know the number is greatest, right? Well, this is talking about the rate at which people come in. This is the rate at which people leave. So I don't want those. I want the number to be greatest. So that's why I wrote this. Then I just remembered, flashcard. Any value will be greatest at a critical or end point of that same thing. Then I also remembered another flashcard that says n has a critical point when the n itself has a tangent slope of 0, or undefined, which means n has a critical point when n prime is equal to 0. So that was my logical sequence of ideas. So now I need to find when n prime is 0. So I did that. Then I remembered the fundamental theorem, which says I can integrate n prime and find out by what amount does n change. By knowing how much n changes and by knowing what n starts out at, I can find out what n becomes. So really, it's a sequence of thoughts that are required to answer this question, not just one.
Is there an equation that you could write for n?
You could write this if you want. You could say n of any time, oops, bad, hold on. So n at any time is going to equal the value of n at time 9 plus, we did this last time, the integral from 9 to whatever time you want of n prime, and then these variables can't match, so I'd use z. Yeah, you can do that. Okay. Is that your question?
Yes.
2 points. Please.
So how do you put that if the derivative of n is dut minus L?
So it's tied to making sure you understand the meaning of the symbols. So I'll talk with you, and then I think it will click better. So what's the meaning of n?
So n is the number of people in the park.
Awesome. So n's the amount.
Yeah.
Therefore, what's the meaning of n prime? Just the mean.
So the rate at which they change.
Perfect. So n prime is the rate at which the number of people in the park changes. Well, there's only two things that cause the number of people in the park to go up or down. People coming in or people going out. So the rate at which they come in, let's say that rate is 200 people per hour. And let's say the rate at which they leave is 30 people per hour. Therefore, the number in the park will be changing by what rate?
What was the first number?
So the first number is 200 people per hour coming in, 30 people per hour going out. So by what rate will the number in the park change?
Minus 30. Plus 170 per hour.
Plus 170 people per hour. That's why I simply subtract the in rate and the out rate, and it gives me the overall rate.
And since that's rate, you don't have to put the beginning amount of people in there.
Yeah, you would not want to do that. That would be incorrect. Because these are rates. They're people per hour. They don't have anything to do with the amount that is there to start with. You don't want to mix amounts with rates.
So like the number of people amount, so n is just the amount.
N is the amount. Yeah, all eyes on me, everybody. Weston, look up. This is a crucial point. Do not mix rates with amounts. The rate is people per hour. The amount is just number of people. So look at my equations here. This equation does not mix the two. It's saying the rate at which n changes. Well, n's rate would be some people per hour. This is people per hour, this is people per hour. The units are consistent. Down here on the integral, you'll notice I'm not mixing amounts and rates. Because when I integrate the rate, the units of n prime are people per hour. The units of dt are just hours. So when I integrate, the hours divide out, and the integral gives me a number of people. So when I integrate the rate, I get a number of people. It's the amount by which n has changed. So your units must be consistent and must make sense. So don't mix them. If I answered your question, I don't know. Okay. Please, Alice.
So in most of these columns, you're integrating a rate, like all of them?
I don't want to ever say all because they're clever, but generally, if I'm trying to find when some amount is greatest, I am going to end up integrating the rate at which that amount changes.
So it's always going to be a prime version?
Most likely. Always is a little strong, but yeah, most of the time. 2 points. And that's the key, Ellie, is that in your solution, you've got to make sure that your solution correctly lists n when it's supposed to list n, lists n prime when it's supposed to list n prime. Again, if you get them mixed up, the grader's going to give you 0 points because your solution won't make any sense. Please.
Why are you adding 0?
So the integral doesn't ever tell you how many people are in the park. It tells you by what number does the number in the park change. So from hour 9 until hour 15, this integral's value is 3950, about 4,000. That means the number in the park changed by this amount during that time period. If the number in the park had started at 5,000, then there would now be almost 9,000 in the park. It started at 0, so you don't have to technically write the 0, but I want to keep emphasizing that the integral is not finding how many are in the park, it's finding by what amount has the number in the park changed. That's crucial for all future problems. I'm not sure I answered your question. Okay. 2 points for Hayden. Anybody else? Let's go to number 2. Okay. Number 2 is the same situation as the blue packet. So the situation is not new. It's gallons of pollution in a lake. A couple of differences between number 1 and number 2. Number 1, they did not give a symbol for the number of people in the park, so we had to create one. So here's us creating the symbol. Hold on a second. So we had to write N of T. In number 2, you don't have to do that because they tell you right up at the top. P of T represents the number of gallons of pollution in the lake. So you don't need to write down P of T. They've already told you. In number 1, we had to indicate that n prime was the in rate, subtract the out rate. In number 2, no need because they just give you a formula for P prime. So we can just say, let's see, they want to know at what time will the number of gallons be least. So number of gallons is P of T. So P of T is least at a critical or end point of P. Don't put P prime. That statement has nothing to do with P prime. Question. So now we need to go find where P prime of T is equal to 0, just like we did on the last problem. So do that on your calculator. Go. The formula is a little hard to read on your sheet, so the formula is right there on the screen. So it's back to what we memorized in September. P is going to be lowest at a critical point. P has a critical point when the tangent slope of P is either 0 or undefined. And the tangent slope of P is equal to 0 when P prime is 0. Trying to figure out when P prime is equal to 0.
Change it by a little bit. I just changed it to that was hilarious. That's a little just not let
So what I do is I always window 0 to 5, and then I just keep windowing until I get a picture that I feel comfortable with. So I windowed 0 to 5, 0 to, I guess I tried 5 first. Zoom fit. This is my graph of P prime. The x-axis is up here. You can see the tick marks. So from time equals 0, from day 0 to day 5, I do not see P prime ever hitting 0, so I need the window bigger. So I just double. So go to 10, zoom fit. I can tell, well, that's interesting. I didn't do the right zoom fit, I think. Zoom fit. Still not big enough, so I go to 20. Oh, that's trace, that's what. Stop it. Pressing on will stop the graph, so if you know something's wrong, just press on. Then zoom fit. Still not enough. Keep going. Showing the axis now. I should have paid attention to that earlier. As soon as the axis appears, I know it's going to hit the axis. So there we go. Zach?
My graph isn't showing graph.
Let me come look. Hold on. Anyone else need help waving me up? Come on. So P prime is equal to 0 at t equals, what is it?
30.17.
You need help with that? Make sure you save that number. Okay, so therefore, P of t is least at the beginning time is 0. The critical point, time A. The final end point, they don't give one. So that means it could be greatest at infinity, or least, I should say. Question? So now you go find how much, again, switching back and forth between P and P prime, be careful. So now you go find how much pollution is in the lake at each of those times. So P at time 0 is given, 50 gallons. P at time A is going to be, there are 50 gallons to start with. The integral of P prime will not tell me how many gallons, it'll tell me how much the gallons of pollution changes during that time. So when I integrate P prime from time 0 to time A, the value of the integral will be by what amount did P change during this time period. That's why I must combine it with the 50. Somebody have the integral? Looking for somebody to tell me the value of the integrals.
Negative 14.896.
2 points for Mikkel. Can somebody confirm that?
Yeah.
Okay. Remember, the negative 14 is not the amount of pollution in the lake. The negative 14 is by what amount did the amount of pollution change. Fundamental theorem says when you integrate the rate at which the pollution level is changing, you find out by what amount does that pollution level change. So the level of pollution, somebody number please?
35.015.
1040.
Yeah, sorry.
Who got this to work? Hands up. Show me your hand. 2 points. Okay. Question? Roger, please. Yeah, here's the problem. Everybody eyes on the board. Everybody. Okay, on problem number 1, we did not run into this dilemma. We figured out that the number of people in the park would have to be greatest either at time 9, A, or 23. And then we just found out how many people are in the park at those 3 times. This problem, you've got to do something different to get the final point that is available to you, or the final point as far as the justification. You have to look at your graph of P prime, okay? And you've got to make sure P prime doesn't come back. So I just kind of window out further until I feel pretty comfortable that P prime's going to just keep going up. It's either using my calculator or using my memory to remember how functions behave. So this is easier for me. Okay, it looks like P prime just keeps going. Okay, question for the whole room. For all of this time, so whenever t is greater than 30, P prime is positive. Say it out loud, please. If P prime is positive, what will P be doing? Increasing. That's what you write on your paper. So come back here and say, for t greater than a, P prime of t is positive, so P of t is increasing. So I can't really find what the value of P is at infinity, but I don't need to. Because if P is just getting bigger and bigger and bigger, the lowest point's got to be time A. You need me to talk through that again? So that's what you write down. So your conclusion should say P of t is least at t equal, make sure you have units, 30.174 days. They want to know what is the amount at that time. Nothing indicates rounding. So P of t is least at time equal 30.174 days, where the amount of pollution at that time is equal to 35.104 gallons. Question? Just watching people's pencils. Okay, number 3. Please.
For the previous one, for the blue ones, the units, so just gallons.
These would just be gallons, because P prime is the rate at which the pollution level is changing. So P prime is gallons per hour. No, sorry, gallons per day. dt means difference in time. So time is measured in days for this problem. So the days divide out, and the integral gives you a number of gallons. You don't have to put the units along the way in the end. Point? Anyone else? Okay, number 3. 3 talks about a moving particle. That's not new. It says, what is the greatest distance between the particle and the origin? So the particle is moving back and forth. The origin is always the center. The particle is located at location 1 when time is equal to 0. So here's where the particle is. Location 1, time equals 0. Question says, what is the greatest distance between the particle and the origin? At time 0, that distance is 1. They want to know what is the greatest distance. So as the particle moves, if it ends up way over here, that distance will be further from the origin, because it will be the distance between my hands. If the particle ends up over here, then the distance would be furthest from the origin between my hands now. So really, when the particle is to the right of the origin, its position is positive. When the particle is to the left of the origin, its position is negative. So the question is really wanting to know, what is the most and least value of the position? So I'm going to write down, let's see, x of t is greatest and least. Lowest meaning most negative value. So x of t is greatest and least at a critical or end point of x. The orange statement does not involve velocity. We're talking about the position. Please, Zach.
Could you say the absolute value of x of t is greatest at a critical endpoint, or do you need those two values, the greatest?
That would be fine, what you just said. Yeah. Either one of those. Perfect.
Do you have to label x of t to be the position since they don't give you?
Outstanding question. 2 points for Hadley and Zach. No. For the AP test, if the part was moving back and forth, it is assumed that x of t represents the position. So you're fine on that one. 2 points for the outs. Cool. So we just do the same thing as before. X of t is greatest. So now we got to go find the critical points. So x will have a critical point when the derivative of x is 0. So we're looking for when the velocity is 0. So do that on your calculator, please. Welcome to the AP test. They always do stuff like this to you. Like you feel like everything's under control, and then they throw some weird, wobbly thing. There's no end time, so you just start playing around to try and kind of see what the graph looks like. I would start at time 0 because it mentions that. So I went 0 to 5 to start with. I'm like, great. So then like 0 to 10. My calculator is the slowest one in the room, so it's very exciting. Seem to have a bit of a pattern, so I'm pretty content. Okay, I'm not going to go find all those zeros. There's too many of them. So I'm just going to kind of start going down the path and see what happens. So, key thing on the AP test, listen, you don't want to get bogged down. You want to keep moving. So just got to kind of work on relaxing. Just like, okay, I'll just do what I always do. So I can find some of the zeros. I remember from last period, like the first one's at 2.507. Can't remember the others. I want to store that, so I need to put that in A. Then I'll find another one. Good for help. Like make it a race and say 3 points for the 0, 4 points. Boston?
3.545.
3.545, 4 points for Boston. Trouble with this game is you all wait until the bidding just keeps going up. I'd find one more 0. Kind of go that far and see what happens. I wouldn't keep finding zeros. Tristan?
4.342.
4 points for Tristan. 4. Yeah, why not? Questions? Cool. Now we go find the position at those times. So I'm going to say the position at time A, actually position at time 0 I know is 1. I need to list that. Position at time A, again, don't mix up velocity and position. Otherwise your solution makes no sense. You get 0 points. So x of A is going to equal 1 plus. I integrate from time 0 to time A, the rate at which the position is changing. The integral tells me by what amount does the position change. Looking for the integral, somebody?
Negative 3.265.
Negative 3.265. 4 points for Michelle. So the particle starts at 1. Over the next roughly 2.5 seconds, the position becomes about 3 more negative than it currently is. So the new position is negative 2.265. So far that's where the particle will be most distant of the origin, is right here. But we need to check the other critical points, so I keep going. So the position at time B is 1 plus the integral from 0 to b of the velocity. Please.
For the AP test, you have to write out, after you wrote 1 plus the integral, the next one, do you have to write 1 plus that number, or can you just add them?
Gotcha. For the AP test, you can just write, you can skip writing this.
Yeah.
I write it just to clarify what we're talking about, making sure that hopefully the understanding is solid. 2 for Maya. Somebody know the integral? Please.
Negative 0.609.
4 points for Trey. So what's this number, Trey? Help me out.
0.391.
4 points. Question? So far, particle starts at 1, goes, let's look at the graph of the velocity here. So the particle starts at 1, the velocity is negative until time 2.5. So the particle would go from 1 straight left until it gets to 2.5. Then the velocity is positive for the next, till about time 1 to 3.5. Particle comes back right, so it gets to about here. Now let's keep going. So find the position at time C. Somebody have that integral?
Negative.
Let's go, Maddie.
Negative 3.115.
So 1 plus negative 3.115. 4 points for Maddie. So this would be negative 2.115. I'm probably going to stop now and just make an assumption that that pattern is going to continue. That the particle is just kind of bouncing back and forth, and it's getting closer and closer to the origin. I'll be honest, that might cost me a point if I don't have more justification, but it's not worth my time on the test to keep trying to figure out what they want. So I just write down the answer. The particle, actually we just say x of t. So x of t is, actually they said, what's the greatest, so I have to say this. The particle, let's see, how do they ask it? Greatest distance. The greatest distance between the particle and the origin is, distance would be a positive number, so 2.265. No units on this problem.
Is it only?
I always read the problem again to make sure that I don't make a mistake of leaving something out. So I come back up and carefully read. What is the greatest distance between the particle and the origin? So they didn't ask for the time, they just want the distance. They didn't say anything about rounding, so I'm good. Please.
What do you mean by justify your answer? Is that just
The other stuff is the justification. Now, 2 points for Maya. Warning to the whole room. Okay, justifying your answer is not just showing your work. It's showing specific key elements that they're expecting to see. So the key elements that they're looking for, the statement in orange you don't have to write. I have you write it, so hopefully you'll get it memorized. The statement in green, you get points for that. That's part of the justification points. The integrals, that's part of the justification points.
Is the stuff in green saying what you're, like, on the other ones you gotta say that it is the least at like t equals 0, a, or t equals infinity?
Yep, same thing. My dilemma here was there were critical points for forever. So I wasn't really sure how to handle that. This probably might not be quite good enough for justification, but the way they justify it is really hard to write out. So this is good enough. So, 2 points. Okay, I think you can do number 4 on your own, so go. I'll just help. Just stop me if you have any questions at all. someone have the value of this integral? Or does somebody have the combo? We can do the combo this time.
149.408.
So 149.408. 2 points for Mikkel. Someone have the next one? Go.
How did you find n is 0?
So this one, just always read slow and careful. No worries. They put it up here somewhere that, oh, here we go. The tank contains 125 gallons of the oil at time equals 0. Good question, 2 points. Someone have the next value here? Tristan?
120.738.
2 points for Tristan. Someone have this value?
122.026.
122.026. So then you just write your conclusion. They're asking for when the gallons is least, at what time, and what is the volume. They don't ask for any rounding. So you write N of T is least. At T equal 11.319 hours. And the number of gallons at that time is 120.738 gallons. Okay, the answers in the back aren't very reliable, so I'm going to try and rewrite the answers and post them on my website. So watch for a text that will indicate that. So, but there's only 4 more problems for the homework. So good work. Well done.